Okay, this video is going to go over optimization, but more importantly, how to use the calculator for optimization problems. If you don't have the calculator that I've given you, that's going to be on this video. Make sure that you are privy to how to use your calculator because there are a lot of different calculators out there and they all operate in a different way. If you have a TA83 Plus, that's going to be the same instructions that are in the year-long folder on Calculator Resources. It tells you how to enter your script into the calculator so the calculator can do what you want it to do. This video, again, will be mostly for people with TI-84 pluses, CE or not CE edition. This is from the Golden Ticket for Unit 4 Optimization. It says, the figure above shows a rectangle described in a semicircle with a radius of 20. The area of such a rectangle is given by a of x equals 2x times root of 400 minus x squared, where the width of the rectangle is 2x. Find the dimensions of the rectangle with the maximum area. So as I had noted in class, it's important to consistently read the problem over and over and over again until you get all the math out of the words there. So I'm just going to try that again. Figure above shows a rectangle inscribed in a semicircle. Okay, so this part is a semicircle. I'm going to use this marker. This is a semicircle here with a radius of 20. So at any point the radius is 20. Anywhere on there, the radius is 20, which is good to know. Now, the area of such a rectangle is given by 2x times root 400 minus x squared. That's really nice that they gave that to you. And I'm going to have a little bit of a cough attack here, so hold on just a second. Yep. False alarm, that was a yawn. So again, it's nice that they gave you 2x times root 400 minus x squared as the area. The way they got that is that they said that this was x. And that means for symmetry that this side was x also, so the total together was 2x. That's where they got that 2x from. And then the root 400 minus x squared, well, the equation of a circle is x squared plus y squared equals 400. And they solved that for y for you and got that the root, the y value for any point on the circle, the y value here or there, is always going to be root 400 minus x squared. So find the dimensions of the rectangle with maximum area. So what we need to do, what they're asking us to do, is to do, take this equation, a of x equals 2x times root 400 minus x squared, and find the maximum area. Now generally for us, we take the derivative set it equals 0, and we're going to solve for x. And the value that we're looking for x is going to be equal to something, and we want a prime of x to change from positive to negative. Now we should also note the any kind of domain here. If x was really, really close, if x was here, the area of the box would basically be 0. And if the x was vertical, going up here, like the x was super, super small and went up here, again, that distance would be, that area would also be 0. So as far as the domain is concerned, it doesn't look like we have to consider endpoints of this interval. It does look like we have to consider the actual function. Now, there's two ways to go about this. You can take the product rule and do the derivative by hand, or you could LTC DTW, let the calculator do the work. And here's what I'm talking about. Let's go here, and what I'm going to do is I'm going to go to y equals. Now I'm going to enter the first equation that I gave myself, 2x times the square root of 400 minus x squared. Holy moly, this is weird to use. 400 minus x squared. Okay, so I entered that in y1. I'm going to go back to the beginning here because I actually don't want that equal sign to be selected. Now I can graph this function and see where the maximum occurs. The only problem is the window is going to be probably a little bit of a pain in the butt, and I don't really want to do that. So I'm going to go to y2. Since this is a calculator problem, I'm going to do math 8. Math 8 gets me that derivative and derive. So I'm going to go math 8. And I'm going to ask me for ddx. What does it want the derivative of? Well, it wants the derivative of y1. How do I get y1 in here? Alpha trace. That's from a video, y1. And what do I want x to equal? I want x to equal x. And what that line is saying is, and what you're asking the calculator to do, is to take the derivative of the first equation but just graph it. I don't need to know what the actual equation is, and in fact, the calculator can't give you the derivative of the product rule here. It can strictly just get you slope values for any window that you provided for the original function and plot those. That's all it does. So we're going to look at a graph of the slopes of the original function. And what we're interested in for a maximum area is where the slope changes from positive value to a negative value. I'm going to go and do a zoom 6. I'm going to standardize this window, and it looks like I have absolutely nothing. Oh my gosh, is that really right? Zoom 6? Oh, that looks crazy town. Okay, so let's go and go try something else here. Let's go and do a window, and I'm just going to look at the window here. It looks like negative 10 to 10. I know that it's not going to be a negative value because of the symmetry, so I'm going to just change this to 0. And then I'm going to change my max. I know that my radius could be up to 20. If you're looking back at the original problem, the radius can only be up to 20 because if the radius is 20 here, then I get 0. So my maximum value has to be 20. I'm going to change my x scale to 2 just so I can read it easily. I'll change this to 5. Negative 5 and 5 for no particular reason. I just want to have a nice window. And please, ooh, look at that. I see a change in sign from positive to negative on the red graph. That's perfect. So what I want to do is I want to get that value. I want to get that x-intercept. How am I going to get that x-intercept? I got to go second trace. If you scroll down to second trace, not scroll down. If you go to 0 on second trace, and now you move your left and right arrow keys so you can see the cursor. Here's the cursor. I want the cursor on the left side of that root, and for the right bound, I want the cursor on the right side of the root, and I want it to guess inside of that, and it says 14.142. Okay, so what is the calculator is saying is that when x is about 14.142, that area is at a maximum. And I don't know if I necessarily believe that, so I'm just going to double check on the calculator. Not required, but I'm just going to double check anyway. I'm going to go back here. I'm going to deselect this equal sign here. I'm going to go back up to the top and select that. The way I selected them, by the way, was just going to was going back to the equal sign, having my cursor over the equal sign, and pushing enter. Okay, now I'm going to graph the original function. The graph's not going to come out so well. I can kind of see a little bit over here on the left, but I can't really see much more of it. So what I'm going to do is I'm going to change my window here. I want it from 0 to 20 because those are values that I'm interested in, but now I need to make this window a little bit bigger. And I'm going to get this to be 0 because I can't have negative area. So I'll have my y min be 0. But this time I'm going to have my y max. It uses a number like 400, so I kind of want to use something like that. Let's use 400. I don't think that's going to be the actual scale I need. I'm just going to play around with the window to make sure I have it right. Put this in 50s. Ooh, okay, that actually kind of worked better than I thought it would. And you can see here that at this point, at about 14 point something, the area, the y1 value, and I did that by doing trace, the y value is actually the max. So this works out perfectly, 14.14, and it looks like I'm getting a max of 400. I hope there's no question on this. If there is, you know how to ask, where to ask, and I sincerely hope that this helps you with your calculator problems. This is how I'd use a calculator to find a maximum. Please notice I let the calculator do the work. I did not do any product rule, quotient rule. I didn't do a line test, sign chart, anything of that nature. I strictly let y1, I'm just going to write this out so people can see it. I let this be equal to y1, and I said y2 was going to be equal to d dx of y1 when x equals x. And then I graph that. I'm just going to remember this. This is step 1, step 2, this is step 3. Graph, and then look for the sign change with a root. Look for zeros. This is a much longer video than I intended, but I hope it's helpful. Is zero spelled with an ES? I don't know. And then look for zeros. That's it. Good luck, guys. Thank you.